This lesson, we're going to learn how to do optimization that involves exponential functions. Example number 1, given f(x) is an exponential function, we want to find the absolute maximum and minimum values of the functions on the indicated interval. Step 1, let's find the first differentiation. When you differentiate exponential function, first you copy it down, you times by differentiation of the exponent, and times by ln of the base, e, minus e to the power negative 3x, times by differentiation of the exponent, which is negative 3, times by ln of the base. And that simplified it. We know ln e is 1, so we can write negative e to the power negative x plus 3e to the power negative 3x. And next, we have to common factor it. So they have e to the power negative x, they have e to the power negative 3x. They have the same base, but since negative 3x is smaller, so we're going to factor out e to the power negative 3x. And you're going to have negative e to the power 2x plus 3. After we have the first differentiation, we let equal to 0 to find the critical point. That means either the first term will become 0 or the second term will become 0. And that's solved for x. So the first one, e to the power negative 3x equals 0 means 1 over e to the power 3x equals 0, which is impossible. Because the numerator is not 0, so it will never become a 0. Or negative e to the power 2x plus 3 equals 0. That means 3 equals e to the power 2x. Let's take ln on both sides. And when you take ln on both sides, you can bring the exponent down. And we know ln e is 1. That means ln 3 equals 2x. That means x equals ln 3 over 2. Since we need to make sure our critical point is within the domain 0 and 10, so we have to use calculator to find the approximated value. So you have to do ln 3 divided by 2. You will see x, it's approximately 0.5493. That means it is within the domain 0 and 10. Now let's identify our critical point by drawing a number line for f prime. Put the critical point on, which is ln 3 over 2, and that boundary is 0 and 10, and let's check the positive negative interval. On the left-hand side, it's positive. On the right-hand side, it's negative. That means going up, coming down, that's a local maximum. And we have to check our endpoints, because right now our endpoints are using a square bracket here. That means including the 0, including the 10. So we have to check the endpoints at 0 and 10. And let's check the y values. How do I find the y values here? Substitute those x values into the original equation to find the y values. And you will get 0.3849 at the critical point. And when x equals to 0, y is 0. When x equals to 10, y is 0.0000454. So as you can see here, the highest value is actually at 0.3849. So we say this is the absolute maximum, or you can say that's global. And 0 is actually a minimum. So we say this is a global minimum. Therefore, we say the absolute maximum value is 0.3849 at x equals ln 3 over 2, and absolute minimum will be 0 at x equals 0. For part B, the function g is actually composed of two functions being multiplied together. So when you differentiate it, you have to use product rule. So differentiation of the first function, which is 1, e to the power negative 2x, plus x plus 2 times by differentiation of the second function, which is an exponential function. So you copy it down, times by differentiation of the exponent, times by ln e, which is 1. So we don't need to write it down. Next step, simplified it. And we're going to common factor out e to the exponent negative 2x and expand and collect the like terms in the second bracket. Once again, you have to let G prime to be 0 to find the critical point. The first term, e to the power negative 2x equals 0, or negative 2x minus 3 will be 0. Because the first one is a negative exponent, that means it's in the denominator, but the numerator is not 0, so therefore it will never be 0. That's invalid. Next one, negative 2x equals to 3, that means x equals negative 3 over 2. And once again, you have to see whether or not this critical point is actually within the domain. And this is negative 1.5. This is in between negative 4 and 4. So it is our critical point. After we have the critical point, then we have to identify whether or not this is a maximum or minimum. So there's a G prime. Put the critical point on, negative 3 over 2. Put the boundary on. And that's check the positive and negative sign. Left is positive, right is negative. That means going up, coming down, that's a local maximum. And that's checked with the endpoints, which is at negative 4 and 4. And once again, you have to substitute those x values back into the original equation to find the y values. And as you can see here, the highest y value will be at 10.04. So this is the global maximum. And lowest y value is the negative 5,961. So we say this is the global minimum, which is the absolute minimum as well. Therefore, we will say the absolute maximum value is 10.04 at x equals negative 1.5. The absolute minimum value is negative 5,961.92 at x equals negative 4. Example number 2, a squirrel population in a small self-contained forest was studied by a biologist. And the biologist found that the squirrel population P, which is measured in hundreds, it's a function of time where T is measured in weeks, and the function is given here. So first, we have to determine the population at the start of the study. So when we're finding the population at the start of the study, means T equals 0. Let's substitute 0 into T into the original equation to find the initial population. And we know 0.02 times by 0 is going to be 0. And e to the power 0 is 1. That means we're going to get 20 divided by 4, which is 5. So the population is 500 squirrel because the units are in hundreds. Part B, the largest population the forest can sustain is represented mathematically by taking the limit t is approaching to infinity. And we're going to determine this limit. So the first thing we do is we put infinity into t. And negative 0.02 times by infinity will be negative infinity. Because the exponent is negative, that really means 1 over e to the power infinity. And e to the power infinity is a huge number. So 1 divided by a huge number, it becomes very small, which is almost 0. So we're going to have 20 over 1 plus 3 times by 0, which is 0, which is 20. Because the units are in hundreds, so we say there are 2,000 squirrels. Part C, they want us to find the point of inflection. And point of inflection can be found when the second differentiation equals to 0. So we're going to find the first differentiation, and then we're going to find the second differentiation, and we're going to let it equal to 0. First, I am going to manipulate the original equation. So instead of write as a fraction, I am going to bring it up. So I can use chain rule. So P prime will be 20 times by negative 1, negative 20. And do not change the base. Exponent take away 1, so negative 1 minus 1 is negative 2, and times by differentiation of the base. So differentiation of the 1 is 0, and then differentiation of this will be 3 e to the power negative 0.02t, because that's exponential now, times by differentiation exponent, which is negative 0.02, times by ln of the base, which is ln e, which is 1, and we don't need to multiply them. That's simplified it. You're going to get 1.2 e to the power negative 0.02t, 1 plus 3e negative 0.02t to the exponent negative 2. Once you have the first differentiation, then we can move on to the second differentiation. And as you can see, this becomes a product rule. So p double prime t. So differentiation of the first term, which will be 1.2 e negative 0.02t times by negative 0.02 times by ln of the base e, which we don't need to write it down. And copy down the second function, plus copy down the first function, and times by differentiation of the second function now. So negative 2, bring it down, 1 plus 3e negative 0.02t to the exponent negative 3 times by differentiation of the base, which is 3e negative 0.02t times by negative 0.02. Once again, ln e is 1, so we don't need to write it. Now that's simplified it by looking at what they have in common, so we can common factor it. So 1.2 e negative 0.02t, that's what they have in common. They have negative 0.02 in common. They have 1 plus 3e negative 0.02t to the exponent negative 3. And this becomes 1. Then simplify the square bracket by collecting the like terms. So you do 3 minus 6, you get negative 3e negative 0.02t. Once we have the second differentiation, we let it equal to 0 to find out the point inflections. So 1.2 cannot be 0. E to the negative 0.02t, because the exponent is negative, that means it's in the denominator, then it will not be 0. Negative 0.02 cannot be 0. Once again, this term here is a negative exponent. That means it is in the denominator. That means it will not be 0. So the only one that could be 0 is the last bracket. Now let's find t. 1 equals to 3 e negative 0.02t. Take ln on both sides. And when I do ln, because that's a product, 3 times by e, so I can write as 2 ln by using addition. And ln 1 equal to 0, and ln 3 plus, because that's exponent, so I can bring it in front of the ln e. And ln e is 1, so it becomes ln 3 minus 0.02t, and bring the t to the left-hand side. And let's get rid of the decimals. So we're going to times by 100. And divided by 2, you get t equals to 50 ln 3, which is approximately 54.93. Since we're finding the point of inflection, that means we also need to know the p-value. So substitute t equals 50 ln 3 back into the original equation. You will see p is 10. Therefore, point of inflection is at 50 ln 3, 10. Since this is not a maximum or minimum, so we don't need to identify it. It is a point of inflection. Now let's put every single information on the graph. So initially, you start with the 500 squirrels, and as the time goes on, you're going to reach 2,000 squirrels eventually. And what does it really mean by the point inflection? It means this: even though the population of squirrels is always increasing, but the rate is different. Originally, the rate of growing is getting faster, and after point inflection, the rate of growing is getting slower. Example number 3. If a drug is injected into the body, the concentration of the drug C in the blood at time t is given the function here. So it depends on the drug, the values of A, B, K are different. However, A, B, K, they are all positive constants. So we want to find at what time does the largest concentration occur. Since we're finding the largest concentration, that means we want to find C prime. And since A, B, and K are constant, so this will become our coefficient. We just need to differentiate inside the bracket. Then let's simplify it and let it equal to 0 to find the critical point. Since B is bigger than A, and K and B and A, they're all constant, this will not be 0. So the only value that can be 0 will be inside this square bracket. In order to find T, let's move this term to the left-hand side and take ln on both sides. And then because this is multiplication, so we can write as 2 ln using addition. Same thing here. Next, we're going to bring the exponent down in front of ln e, both of them. And ln e is 1, so we can write like this. Ln a minus at equals ln b minus bt. And that's isolate for t. So bt minus at equals ln b minus ln a. That's factor out the t on the left-hand side. And t will be ln b minus ln a over b minus a. And that's our critical point. Since we need to identify this critical point, so we cannot use all the variables around. So let's make some assumptions. I let a equals 1, b equals 2 because b has to be bigger than a, and k equals 1. So they are all constants, they are all positive, and b is bigger than a. And that's substituting to the critical point. So t will become ln 2 minus ln 1 over 2 minus 1. And we know ln 1 is 0 and 2 minus 1 is 1. So our critical point now becomes ln 2. At the same time, you have to substitute those 3 values into your C prime in order for you to check the positive and negative intervals on your C prime. And are those the only 3 values you can choose? No. You can choose any values you want as long as they are all positive and B is bigger than A, then your result will be exactly the same. And before we put it on the number line, we want to make sure this is actually fitting to our domain. So what's our domain here? Domain is all the possible values for time, t. So we're talking about the drug is injected into the body. That means t must be greater or equal to 0. After that, we are ready to do C prime on a number line. And put the boundary on 0. Let's check the positive and negative sign. You see positive and negative going up, coming down, so there's a local maximum. And there's the endpoint at 0. Now we have to find the concentration value. So we have to substitute those t values back into the original equation. And remember, A is 1, B equals to 2, and K equals to 1. And you're going to have 1 over 4 and 0. Then we will say the local maximum is actually the absolute maximum. Therefore, we say the maximum concentration occurs at the original critical point, T equals to ln B minus ln A over B minus A. Example 4. A colony of bacteria is growing at the rate 2 to the exponent T over 5. And then the colony is allowed to grow for 60 minutes, and then we introduce a drug to kill the bacteria. And the killing rate is e to the exponent T over 3. So we want to determine the maximum number of bacteria and the time when it occurs. First step, we have to figure out our equations. So we have to find the amount of bacteria will be present, which we call them population of bacteria at time t. So the amount of bacteria present should be the amount of bacteria that has been growing, take away the amount of bacteria that has been killed. But right now, the time is different because growing is actually 60 minutes more than the killing. So we have to add 60 onto the time for the growing. Next, we have to figure out the domain. The variable that we use in the domain is t, so we have to find the restriction for time. So time here represents the amount of time in minutes after the drug that is being introduced. So we say t is greater or equal to 0. After we figure out the equation, we should simplify it. So I will break the exponent apart. And addition of the exponents really means originally is a multiplication between two powers. So I can write as 4096 times by 2 to the exponent t over 5 minus e to the exponent t over 3. And that's my function. Next, we're going to find p prime. So 4096 is the coefficient. So differentiation of 2 to the exponent t over 5 is exponential function. So you copy it down, times by differentiation of the exponent, which is 1 over 5, times by ln of the base, which is ln 2, minus e to the power t over 3, times by differentiation of the exponent, which is 1 over 3, times by ln e. Since ln e is 1, so we can simplify the equation to this line here. Next, we like p prime to be 0 to find the critical points. So 0 equals to the entire p prime here. Now, since we're finding the variable that is in the exponent, I have to take ln. But if you want to take ln, you cannot have any addition or subtraction. So we have to remove this term and put it on the left-hand side. And then we're going to take ln on both sides. And when we take ln on both sides, we get ln 1. Divided by 3 means minus ln 3. Times by means add ln e t over 3 equals ln 4096 plus ln 1 minus ln 5, because that's division, plus ln 2 plus ln 2 t over 5. Now, we know ln 1 equal to 0, so we just say negative ln 3. And we put the exponent down, so plus t over 3. Ln 1 is 1, so we don't need to write it. So ln 4096. Ln 1 is 0, so minus ln 5, plus ln 2, plus, bring the exponent down, t over 5, ln 2. Next, let's isolate the t. So t over 3 minus t over 5 ln 2 equals to ln 4096 minus ln 5 plus ln 2 plus ln 3. In order to solve for t, it it will be easier if we can get rid of the fractions. So we're going to times by every single term by the common denominator, which is 15. So when we times by 15, you get 5t minus 3 ln 2 t equals to 15 times by entire the right-hand side. After that, we're going to come and fetch out the t. And since we want to find t, so we're going to divide both sides by 5 minus 3 ln 2. So this is our exact answer. And if you put on the calculator, you will see t is approximately 38.21 minutes. After you have the critical point, put them back onto the number line for p prime to check the positive negative interval to identify this is a maximum, minimum, or point inflection. As you can see from this diagram here, this is going to be a local maximum. After that, you check with the endpoint by substituting those two t values back into your population equation to see the populations. You will see those two values. Since we're talking about number of bacteria, so you cannot have any decimals. And because it's not becoming one whole bacteria yet, so we're going to round down. And as you can see, this becomes our global maximum. Therefore, we will say at approximately 38.21 minutes after the drug is being introduced, the maximum bacteria of 478,158 occurs. Part B, we want to find the time at which the bacteria colony is liberated. That means completely destroyed. It's gone. That means the population 0, we want to find the time. Once again, because the variable that we're looking for is in the exponent, that means we have to take long. But there is a subtraction, so you can do it. So first thing we need to do is move this term to the left-hand side, and then we take long on both sides. And now we're going to do is we're going to bring down the exponent, and we're going to break them into 2 logs, and also bring this exponent down as well. Then ln e is 1, so we're going to get rid of this. And we are going to bring this term to the left-hand side to isolate for t and times everything by 15 to get rid of fraction. Now we're going to fetch out the t. And divide both sides by 5 minus 3 ln 2. And that will be our exact answer for t. And if you do on the calculator, you will see t is approximately 42.72 minutes. Therefore, you will say at approximately 42.72 minutes after the drug has been introduced, the bacteria colony is obliterated. Example number 5, the effectiveness of studying for a test and the number of hours a student study is being modeled by this equation here. If a student has up to 30 hours that he can spend studying, how many hours should he study for maximum effectiveness? So since we are looking for the maximum effectiveness, we have to find E prime. But before we do that, we have to find the domain. Because it says a student has up to 30 hours. So we know our domain is between 0 and 30. Next, let's find E prime. So 0.5 is a coefficient, so leave them outside the square bracket. Differentiation 10 is actually 0 plus. Now, the next term is actually a product rule, so we are going to use the product rule. Differentiation of t is 1, e to the exponent negative t over 20 plus t times by differentiation of that, which is exponential function. So you copy it down first, times by differentiation of the exponent, which is negative 1 over 20, times by ln e, which is 1, so we don't need to write it. Next, let's simplify it. And we're going to common factor it. One minus 1 over 20t. And then we're going to say let e prime to be 0 to find the critical point. Once we let e prime to be 0, we know 0.5 can never be 0. So either this is going to be 0 or the last bracket is going to be 0. So we have e to the power negative t over 20 equals 0. That means 1 over e to the power t over 20 equals 0, which is invalid because the numerator is not 0. So 1 minus 1 over 20t equals 0. That means 1 over 20t equals to 1. That means t could be 20. And 20 is in between our domain 0 and 30. Now let's identify our critical point. So put it on the number line for e prime. And 20 is the critical point. 0 and 30 is the boundary. Let's check the positive negative sign. You will see this is a maximum. So local max at 20. And let's check with the endpoints. 0 and 30. And substitute all those t values back into the original effectiveness equation to find the effectiveness. After we comparing all the y values, we know at t equals to 20 is actually the global maximum. So therefore, we say the maximum effectiveness occurs when a student studies for 20 hours. Example number 6, a mathematical consultant determines that proportion of people who will have responded to the advertisement of a new product after it has been marketed for t days is given by the function here. The area covered by the advertisement contains 10 million potential customers, and each response to the advertisement results in revenue to the company of $0.7, excluding the cost of advertising. So the advertising cost $30,000 to produce and a further $5,000 per day to run. Part A, they want us to find the limit when t is approaching to infinity and interpret this result. That means I want to know is when the time keeps on going on, how much in terms of the percentage or proportion of the people will respond to the advertisement. Let's take a look at the function when I take the limits. So the function itself has a negative 0.2t as an exponent. That really means 1 over e to the exponent 0.2t. So when t is approaching to infinity, 0.2 times by infinity is still infinity. So we are going to have 0.7, 1 minus 1 over infinity. And 1 divided by infinity, which is a very, very small number, that means 1 minus 0. That means we're going to have 0.7. This means as the time goes on, then we will have 70% of the people that will respond to the advertisement. For part B, we want to know what percentage of potential customers have responded after 7 days. So that really means we are finding f bracket 7. So this is going to be 0.7 times by 1 minus e to the exponent negative 0.2 times by 7. And if you put this on a calculator, you get 0.5273821252, which is approximately 52.74%. Part C, they want us to write the function P, which represents the profit, after T days of advertising. So we know the profit equals the revenue, take away the cost. So what will be the revenue? It says you have 70 cents per each response. So basically is, I would say $0.7 per response times by number of people, which is 10 million, which is 10 to the power 7, times by the percentage of people that will respond to the advertisement, minus the cost will be the amount of money that you have to pay to produce is $30,000 plus the $5,000 per day. So you have to do 5,000 times by T to pay for the advertisement to run. Part C, they want us to write a function, profit, that represents. Part C, I need to find a function, P, that represents the profit after T days of advertising. So we know the profit equals the revenue take away the cost. Revenue is the total amount of money that you earn, and cost is the total amount of money that you pay. So how do I know how much money do we earn? We know for each response, we get $0.7. So we need to find how many responses we will get. So this is how many responses we will get, because this is total amount of people times by the percentage of people that will respond. Next, we have to find the total amount of cost. So we know it costs $30,000 just to produce, plus $5,000 per day to run. So I have to times by T. So this will be the total cost. So we do the revenue, take away the cost, will become the profit. After that, all we need to do is put 7 into T to find what will be the profit after 7 days. For part D now, they want us to find how many days will be required in order to have the maximum profit. So that means we have to find P prime. But at the same time, we need to find our domain. So this is our domain because they give us a restriction on the budget. We know the total cost will be 30,000 plus 5,000 T. That will be the total cost. And I only have $180,000 as a budget. That means the amount of the cost has to be less than $180,000. So that's subtract 30,000 on both sides, and then you divide it by 5,000. You get T is less or equals to 30. So therefore, our domain is 0 less equals to T less equal to 30, because time can never be negative. After we find the domain, then we can find the differentiation now. So P prime, it's going to be, now the first few numbers is all the coefficients. Just write it down. So you only need to multiply the differentiation of the bracket there. So it's going to be negative e to the power negative 0.2t times by differentiation exponent, ln e, which is 1. Next one, 30,000 differentiation will be 0 because that's a constant, and differentiation 5,000t will be negative 5,000. After we have the differentiation, we let the first differentiation equal to 0 to find the critical points, and you have a 0 here. So I remove the 5,000 on the right-hand side by adding 5,000 on both sides, and you will get to 5,000 equals to this entire line. Because we want to find T, so I have to isolate for T. That means I'm going to divide it by 0.7, 10 to the power 7, 0.7, and negative 0.2 on both sides of the equation. And you are going to have 1 over 196 equals e to the power negative 0.2t. And after that, because we're finding the variable that is in the exponent, so we're going to take ln. So ln 1 minus ln 196, because they are division, you can break into 2 ln's using subtraction. And ln e negative 0.2t, bring down the exponents, you will have negative 0.2t equals 2. Now, ln 1 is 0, so it's negative ln 196. Multiply by negative 1 on both sides. And times by 5 on both sides. So you get 5 ln 196 equals to t. And t is approximately 26.39 days. Once again, we have to identify the critical points, put it on the number line for P prime, put the critical points on, and let's check the positive and negative intervals within the domain. So this side is positive, that side is negative, so this is a local maximum. And we have to also check the endpoints. After that, we substitute all those three t values into the profit equation to see which is the greatest profit. After we find out all the values for P, even though we can see this is the highest value, but we cannot use it because these t values are not full days. So what we can do now is we're going to choose a value that is a little bit higher than 26.39 and a little bit lower than 26.39. So we're going to use T is 26 and T is 27 and compare the profit again. After we put T equals to 26 and 27 into the profit equation, we get those two values. And as you can see, this one's higher. So we say the global maximum, which is the absolute maximum, happens at T equals to 26 full days. And this answer will not be acceptable. Therefore, at 26 full days, the company will generate the maximum profit.